Welcome to a video on graphing translations of the basic absolute value function. In this video, the equations will be in standard form with a equal to 1. Standard form of an absolute value function is y equals, or f of x equals a times the absolute value of the quantity x minus h plus k. But again, for this video, a is equal to 1, and therefore the equations will be in the form of y equals the absolute value of the quantity x minus h plus k. Before we discuss how h and k affect the graph, there are a few things we should notice about the graph of the basic or parent absolute value function shown here on the left. Remember, if we're ever not sure how to make a graph, we can always make a table of values to graph the function. Notice how the graph of the absolute value function is a V-shape. In this case, it opens up. The lowest point on the graph, or the point where the graph changes direction, is this point here called the vertex. Notice how the vertex is at the origin, which has an ordered pair 0, 0. Notice when x is greater than 0 or to the right of the vertex, the graph is linear with a slope of positive 1, meaning if we start at any point on the graph on the right side and go up 1 and right 1, we can determine another point on the graph. And then when x is less than 0 or to the left of the vertex, the slope is negative 1. Now going back to the form of the equation y equals the absolute value of the quantity x minus h plus k, the value of h will shift the graph left or right, and the value of k will shift the graph up or down. When h is positive or greater than 0, we would have the absolute value of x minus h. So when we have subtraction here, h is positive, and the graph is shifted right h units. And when h is less than 0 or negative, we would have the absolute value of the quantity x minus negative h, which simplifies to x plus h. So when we have addition here, h is negative, and the graph is shifted left, the absolute value of h units. And now for k, when k is positive or greater than 0, the graph is shifted up k units, and when k is less than 0 or negative, the graph is shifted down, the absolute value of k units. And then finally, the vertex is the ordered pair h comma k. Let's look at an animation to better understand how the values of h and k affect the graph of the basic absolute value function. Let's first see how h affects the graph of the function. Notice when h is positive, the graph is shifted right h units, and when h is negative, the graph is shifted left, the absolute value of h units. So if we stop here for a moment, where h is negative 6, let's determine the equation of this graph. Well, if h is negative 6, and we know a is 1 and k is 0, this would give us the equation y equals the absolute value of the quantity x minus negative 6. Simplifying, we have the absolute value of the quantity x plus 6. So again, when we have addition inside the absolute value, the graph is shifted left, in this case 6 units. And this should make sense because notice how when x is negative 6, the ordered pair here at the vertex is negative 6 comma 0. And notice when x is negative 6, we do have a 0 inside the absolute value. The absolute value of 0 is 0, and therefore the output or y value is 0 when x is negative 6. And when h is positive, let's say when h is positive 4, we would substitute positive 4 in for h, which gives us the equation y equals the absolute value of the quantity x minus 4. Again, when we have subtraction inside the absolute value, the graph is shifted right, in this case, 4 units. And now let's see how k affects the graph. So we'll set h back to 0 and now change the value of k. Notice when k is positive, the graph is shifted up k units. And when k is negative, the graph is shifted down, the absolute value of k units. So here, where k is equal to negative 4, because we have addition here, we normally don't write plus negative 4, we normally just write minus 4. And we know a is 1 and h is 0, and therefore the equation of this purple graph is y equals the absolute value of x and then minus 4. And let's take a look at an equation when k is positive. Let's change k to positive 2. Notice how the graph is shifted up 2 units, and because k is positive 2, the equation of this purple graph, or this graph here, is y equals the absolute value of x plus 2. Let's take a look at a few more examples. Let's say we're asked to graph y equals, or g of x equals, the absolute value of x plus 3. Again, because we have addition here, h is going to be negative 3, we need to be thinking that we can write x plus 3 as x minus negative 3 to determine the value of h, again because in standard form we do have subtraction inside the absolute value. So because h is negative 3, the graph is shifted left the absolute value of negative 3 or 3 units. And so notice how the graph would be this orange graph here, where we have the parent graph or basic absolute value function graphed here in blue. We shift this left 3 units to form the graph of y equals the absolute value of the quantity x plus 3. And then to graph y equals the absolute value of x minus 1, because we have subtraction here, the graph is shifted right 1 unit because h is positive 1. So again, the blue graph is the basic absolute value function. We would take this graph and shift it right 1 unit to graph the given function. And now let's look at 2 more examples involving the value of k. If we want to graph y equals the absolute value of x plus 4, k is positive 4, which means we shift the basic absolute value function up 4 units. So in blue we have the basic absolute value function. Because k is 4, we shift the graph up 4 units to graph the given function. And if we have y equals the absolute value of x minus 2, we shift the graph of the parent function or the basic absolute value function down 2 units to graph the given function. So this is an overview of how h and k affect the graph of the basic absolute value function. In the next video, we will graph absolute value functions that have both a value of h and k in the equation. I hope you found this helpful.